your entire lives, anytime you've measured an angle, you've always said it's 53 what? Degrees. Always. Until today. There's another way you can measure an angle. All right, a different unit than a degree, and it's called a radian. All right, and you're going to figure out what a radian is right now. Here's what I would like you to do on your sheet of paper. Well, first of all, let me back up. Let's hear 30. Don't have one, huh? 2, circumference formula. Two pi d? Pi times diameter, or we also use 2 pi r. You're about to see where this formula comes from right now. Whoever has the compass, here's what I would like you to do right now. Take your compass, make a beautiful, do I still have mine? Yep, there it is. Put your compass point on the paper, and let's make a nice, beautiful circle. But please, maybe somebody else in the group wants to help. Wherever they have their compass point right now, put a point yourself that represents the center so you know where it is. All right, so help your partner out right now. Draw a nice little circle for me around there. Please be accurate where that center point is. So everyone's got a center point and a nice, beautiful circle drawn with their compass. All good? Okay, here's your job for me. What I'd like you to do now is on your circle that you've just constructed, put another point somewhere on that circle. Somewhere on the circle. What do we call if I connected these two right now, the center and that point you put on, what's that called? Okay, here's what I want you to do right now. Everyone's got string. I want you to make a radius out of the string I have given you. All right, there are scissors coming around. All right, so I want you to put your string on the center, put it on the point you made on the circle, cut it to that length, please. Cut it to that length. There are scissors coming around, but just get it measured right now. Please be as accurate as possible, guys. Please be as accurate as possible when you cut this string. I guess I needed instructions on how to use scissors. If you have your own, you can break them out and use them in your group. If somebody in your group has scissors, I don't know if you guys carry them around anymore. Also, while you're waiting, please have a calculator in front of you while you're waiting. We good with the scissors? It's not the greatest of string. Again, please be pretty accurate when cutting your string. One more group here. All good? You just put them right behind you, Bill. Okay, everyone's all good. All right, next job. What I'd like you to do is put one end of your string on the point on the circle you made. Okay, put one end of the string right now on that point you made on the circle. And what I'd like you to do is stretch it around the circle and make another point where it ends. So that arc matches your radius length. Everyone see that? So put one end of the string on the point you made on the circle, stretch it across either direction, and make another point. That's the length of your radius. And what I need you and your group to do together now is please figure out how many radii fit around your circle. Okay? How many radii fit around your circle right now? And everyone, I hope, no matter what size circle you drew, should all have the same answer here. Okay? How many radii can you fit around your circle? So every time you fit it, make a little point. Make a little point every time you fit it around. We all coming up, maybe with the same response here. How many full radii could you put around? 6. Everyone gets 6? But you still had a little extra something left over? 6 didn't go all the way around and you ended up back at your point. Hopefully not. You can't fit exactly 6. It's 6 and then a little extra on here. Everyone, yes, no, maybe? So you fit 6 full ones and then a little extra here, which didn't measure to a full one. Everyone agree? So 6 and change, I'll call it. 6 and change radii. What did you just measure here? The distance around the circle? We got a name for that. What is it? Circumference. John, going back to you, what was your circumference formula? 2 pi r I'll use for this one. How many radii fit around the circle? 6 and change, right? 6 and change. 6 and change radii. Everyone go to your calculator right now. Do 2 pi for me. What do you got? 6 and change. Okay, but we don't say 6 and change in math. That's not really that mathematical. Instead, what we say is 2 pi. So that's where this comes from. R for what? Radius, and how many of them fit around the circle? 6 and change, 2 pi, but we say 2 pi to be a little more exact. Now here's what I want you to do on your paper so I can introduce this radian concept. What I'd like you to do right now is connect your radius to one of the, wherever you put your points. So if you started here and you measured a radius and you put a little mark, measure, what I want right now are 2 segments drawn to 2 consecutive markings. Okay? Right now on your paper. Yes.
When we use the string, did you want us to directly connect the points together, like keep the string straight or bend it so we trace?
It should have fit to the circle.
Okay, so over the line.
It should have fit. Here's what I was looking for. Like if this is my radius length, I'm going here, and then figuring out around the circle,
Oh,
and then putting the point.
that's why we got so close.
Okay?
Yeah, you went like a hexagon.
That's got some angle measure, right? In degrees. I don't know what it is, but now you guys have just constructed 1 radian. That's what a radian is. Ready? When your radius and your arc length match each other. When the radius and the arc length match each other, you have 1 radian. So watch this. Ready? How many degrees in a circle? 360. How many radians can I fit in this full circle? 6 and change. But what did we just call 6 and change? 2 pi. You just found out your first conversion here. All right? I believe, did I write it up here somewhere? Up next page. That 360 degrees is equal to 2 pi radians, 6 and a little bit more radians. Okay? Right? So 360 degrees is equal to 2 pi radians, and you guys just saw where that came from. What I need you to do here with me in the next 15 minutes, and it'll probably go quicker than that, is what if I give you a degree, can you turn it into radian? If I give you a radian, can you turn it into degree? Okay? So first thing we'll do here, go to your notes. How do I change a degree into a radian? All right, how do I change a degree into a radian? You are going to multiply all the stuff on the front is just what we went through. All right, to change a degree to radians, you're going to multiply by pi over 180. This is not good news. Ready? Good news. You do not have to remember this conversion. Go to the last page of your packet. What do you got in the last page of your packet? You have a formula sheet, don't you? Everybody take a look where it says degrees to radians. Everybody see degree to radians? What's it tell you? 1 degree equals pi over 180 radians. So it's already on your formula sheet. Okay? Already on the formula sheet. All right? Pi over 180. Got your calcs ready? Got the calcs ready? All right. Convert 30 degrees into radian measure now. An angle's 30 degrees. What's it equal to in radians? Well, I'm going to take the 30 and multiply by what? Multiply by pi over 180. But hey, here you go. When you're going to radians, you're going to leave the pi in your answer. That's how I know it's radians. All right, you're going to leave the pi in your answer. So all I need you guys to do is reduce 30 over 180 for me in your calculator, which it'll do. All right, so if you go to 30 divided by 180, turn it back into a fraction because I don't want that up there. So math, or if you used a fraction template, it'll do it for you. 1/6. So 30 degrees is pi over 6 radians. Okay? Pi over 6 radians. And you don't have to write the word radians. We know we're changing it into it, but 1 doesn't make you great. Let's go to 45 degrees. So now I'm going to do 45 times pi over 180. Leave the pi in your answer. And reduce 45 over 180. And there's a reason we're doing this, because you're going to use this conversion tomorrow to go back and forth. Here you go. 1, what does it reduce, Matt? Pi over 4 radians. Perfect. How about 60 degrees, everyone? 60. 60 degrees into radians. Matt, again, when you have it reduced. Pi over 3 radians. You're on fire. And finally, 90 degrees, everyone. 90. 16, 90 degrees?
Pi over 2.
Pi over 2 radians. Good. All right. Any issues going from degrees to radians? Not that bad at all. We're going to have to do this tomorrow. That's why I'm showing you here today. All right, let's go reverse now. I don't want to fill this in for you. It's on your formula sheet. You tell me what do I have to multiply by. Go to your formula sheet now, but now look under where it says radians and degrees. Radians first, degrees second. What's it telling you to multiply by now? The reciprocal of what we just did, right? Multiply by 180 over pi. And you'll see why we do that. You'll see why we do that right now. Okay, 7 pi over 6. That's in radians. What was the conversion? Multiply it by 180. Hey, why 180 over pi? Anybody see what's going to cancel out? Pi's are gone. That's why it's 180 over pi. So I can cancel out those pi's. And now you're doing 7 times 180 divided by 6. And what's that going to be in degrees when you're ready there? 20 in degrees? 210 degrees. Yep. 7 pi over 6 radians, same as 210 degrees. All right, keep it trucking. 3 pi over 5 times pi over 180 over pi. Pi's cancel. Four, what do we got for this one? 108. We're coming up to the challenging one here at the end. 5 pi over 3. 180 over pi. 13, what do you got for me here when you're ready? 300 degrees. Whew. All right. Everyone ready for this last one? What don't you see with the radians? Yeah, it doesn't always have to have a pi. The reason we put a pi here, all right, the reason we put a pi, I'll show you, ready? So this was 30 degrees was pi over 6. Would you rather write pi over 6 or, where is it? That number every time. Probably write pi over 6. It's a little bit cleaner. That's why we have the pi in there. Sometimes, though, you might not have a pi. 3 radians. Still going to multiply it by what? 180 over pi. It's 3. That's it. Don't put a pi with it. It's just 3 radians. 180 over pi. What's not going to cancel out? Okay, so put it in your calculator. 3 times 180 over pi. And go nearest degree here for me. Go nearest degree. So don't be shocked if you see a radian without a pi in it. We just put the pi there to clean it up a little bit. 24 when you're ready. 100 and... Does that look good or no? One job. Whoa, where are we going? I'm going to add a question 9 here for everybody. And then you can get to your homework. Bless you. 21, give me a time. 25, give me a time.
7:43.
Okay, how about on the fives? 1. Give me something a little more.
2.
Okay. In radians, what's that angle form when the clock is at 2 o'clock? What is the angle measure in radians at 2 o'clock? Ooh. First thing we need to figure out is how many degrees does a clock go in 1 minute? How many degrees does it go in 1 minute? In 1 minute? You're getting there, though. It doesn't go 360 in 1 minute. It goes 360 in, oh boy, 60 minutes, right? 360 degrees in 60 minutes. Can you find out how many are in 1 minute? 6 degrees. Everyone agree on that now? 360 and 60, 1 minute in 6 degrees. How many minutes am I going from 12 to 2 here? How many minutes? Oh my God. Here to here. How many minutes? Everyone's okay. 10 minutes. Yes, 10 minutes? Right? From here to here is 10 minutes. Yes? So how many degrees then? 60 degrees. How would you find how many radians then? Go 60 degrees, but how many radians? You guys have the conversion. What do I multiply 60 by? Pi over 180. So when it's at 2 o'clock, it'll have an angle of pi over 3 radians. Just was trying to set you up for tonight's question, last question for tonight. All right, take the time right now. You'll be able to finish, hopefully. Okay? Know the conversion. Look back on your formula sheet if you need to.